Sleeping in my jeans all week, trying to find a second just to pause and blink. Wanna switch up all my bad routines. What happened to the days it was just last week? I don't wanna let me down, time to jump a level now. Sit down, sleep now, breathe in, breathe out. I'm in need of fluffy clouds, slow down and forget my doubts. Sit down, sleep now, breathe in, breathe out. Always I've been stuck the same for months now. My grades mostly do not bring me slowing down. Oasis, been dreaming of just fading. Always made me feel the same, same, same. Been forgetting when to brush my teeth, reading up on all fluoride conspiracies. Submerge me in a submarine, somewhere where nobody will hear me scream. I don't wanna let me down, time to jump a level now. Sit down, sleep now, breathe in, breathe out. I'm in need of fluffy clouds, slow down and forget my doubts. Sit down, sleep now, breathe in, breathe out. Always I've been stuck the same for months now. My brain's mostly do not bring me slowing down. Oasis, been dreaming of just fading. Always made me feel the same, same, same. Won't I break from my brain insane or forever? Won't I break from my brain insane or forever? Won't I break from my brain insane? So much I'm feeling. Won't I break from my brain insane? Can't keep considering things. Always I've been stuck the same for months now. My grades mostly do not bring me slowing down. Oasis, been dreaming of just fading. Always made me feel the same, same, same. Always I've been stuck the same for months now. My grades mostly do not bring me slowing down. Oasis, been dreaming of just fading. Always made me feel the same, same, same. this way when I see your face. When I see your face, when I see your face, when I see your face, tell me why does my heart burn when I see your face? You have made your decision, put me in that place, and the lies you've been hiding, taking up a space. Tell me why does my heart burn this way when I see your face? We keep on hiding in shadows, 'cause I'm not supposed to be with you. But I kinda like fighting battles, 'cause I know that I'll never lose. Don't wanna skim the surface, dive right in on purpose, 'cause babe, I know we're worth it. There might be consequences, we should take our chances and ease up all the tension, the tension. I'm gonna do what I wanna do. Oh, it's better when I can't stop thinking about you. I'm thinking about you. I'll say what I wanna say. Couldn't wait another day, 'cause there's something about you. I'll do what I wanna do with you. With you, you, you. Do what I wanna do with you. With you, you, you. With you, you, you. Do what I wanna do with you. With you, you, you. She said that you were her treasure. That's why you could never be mine. Now I can see through it. It's all been bullshit. So I won't let her change my mind. Yeah, she thinks she owns you, but barely even knows you. She moved on to somebody new. She saw you maybe one time, but didn't even catch a vibe. So why we gotta say goodbye? Won't say goodbye. I'm gonna do what I wanna do. Oh, it's better when I can't stop thinking about you.
Alright, hello everybody. Hello for the early comers here for today. I hope everybody's doing well today. Hopefully everybody is doing wonderful and great. I hope everybody had a very nice and wonderful weekend. Hello. Okay. Hey, Susan, good morning, good evening to you. My weekend was great. I got a new used car, kinda. So now I got a car sitting out there that's brand new, so kinda brand new-ish. Overall, I had a really good weekend. How about yours? Yours is good. Went by quick, which is the usual. That's good. As long as you had a nice time. That's all that matters. As long as it went by quick, no problemos. Easy peasy lemon squeezy. And that's perfectly okay. I just was basically kind of waiting for this weekend to go by and be able to come back, teach a little bit more stats, statistics, kind of an important thing. Got a little bit to do here today, though. Just a little bit. Not too crazy, I promise you. Any plans for this week here, Susan? Not much homework and work. That okay, that's fair. That's a given. Why don't you go out, at least do something different? I know that, of course, there's not many places to go. To be fair, I will definitely give you that. Don't you like to do something, something a little different than the usual stuffs? Like my homework isn't all that, my homework is a little time consuming, I ain't gonna lie. But I would hope that you at least put a little variety into your week. Just do a one or two things that are slightly a bit different that gets stuff out of the way. You do any free time? I was gonna say, I'm like, do you really have any free time? It certainly doesn't sound like it. Connor, hello. How we doing, buddy? I know you're fuming today. I know you are absolutely livid. I am in the same boat, my friend. Absolutely livid at these excuses. I don't know if European football in general will ever be the same if they go to this Super League idea. My opinion on it is well, obviously it's a terrible idea. I think it's just basically funneling the money through only a certain select of clubs. I think that it'll destroy any chance of having a pyramid structure actually be viable. But they say, well, football as it stands is not economically viable. So it's like, well, play too many games. What am I? Okay, hang on. Let me put this on screen here. So the big topic for today is basically formation of a European football Super League. Let's see. Perez has been working on this for 2 years, but the pandemic pushed things on. Says Real Madrid has lost 300 million euros in income this year, and they've had to sell players they didn't want to. Why now in April? Because it was time to get an early start for next season. So they had this planned already, set to go from the get-go there, Connor. Seems like it. Will the clubs in Super League let the players go on international duty? We need to change a lot of things. We played too many games. Everything needs to change. Football, as it is right now, can't carry on. I don't know about that. I don't know about that. Will this save Barcelona economically? This will save everyone. Football is going through a really delicate moment. Worst in 20 years. Won't disappear, but it could slip down to a different level. And if the youngsters aren't interested in it, I don't know. You're right. It does affect. You're right. You're right. It does affect every team. Every single team is affected by this. 100% true. I don't. Again, this is just basically a lot of side talk here. They want to play for games. I mean, yeah. I'm going to be honest with you here, okay? Like, if you lose 300 million euros, okay, in a single year of trying to pay your players, okay, then maybe, just maybe, you shouldn't go over your threshold of how much you can spend. You know, if you're given a salary cap, then you are limited in how much you can spend and you can take care of your finances. That's why I was mentioning James' stream, that's why a salary cap is so important, because things like this do not happen because owners cannot control themselves. And this is what happens. And then they basically want to pass off the buck to basically other teams who basically get the short end of the stick. And this is like this is the height of irresponsibility, in my opinion. I think when you say something like that, it's like, you didn't have to lose 300 million euros. You could have budgeted yourself the past 2 years. Yes, nobody saw a pandemic coming, but you had the choice to pay them less amount of money or not get those players in general. You had to let some players go. You know, a lot of clubs let their good players go. That's just how it is. I don't understand what this is actually saying, you know? If you're trying to save Madrid and Barcelona, that's their own fault. Let them fail on their own merits because they decided not to handle their money correctly. Because you pay Messi 100 million pounds, you know, every single season or whatever. I mean, it's ridiculous. Absolutely ridiculous. Everybody else has to pay because of the fires you created. I think that's nonsense. Utter rubbish. You're fighting for the future of football? No, you're not. No, you're not. You're not fighting for the future of football. You're fighting for your own club's future, thinking that football will be destroyed because you decided to make your club go bankrupt. That's what I think. I think you're Real Madrid, you're Barcelona, you're the Big Six, and you've lost a lot of money by doing stupid things with your money. Well, it's your own fault. Don't drag every other club down with you. You need to fold as a club and restructure yourself. You do that on your own. But don't think that running a Super League is going to save you and basically destroy everything that we hold near and dear as terms of a actual structure, actual sustained structure. I mean, it makes no sense. Massimo, good afternoon / evening to you, Massimo. Good afternoon. How are you doing, my friend? How are you doing? You straight chilling? Very good, very good. You sat there. Normally, if Liverpool score, I'll go crazy, but I sat there, had a bit of a drink. I love that club with all my heart, but it hurts to know that they're playing for their enjoyment, and the greed of the owners are taking it away. Players, coaches, and fans don't want it. I agree. The owners that do, the quicker the UK bring in the 50+1 rule, the better. I think that's fine. I think that if you also want a fair rule, you have to start instituting salary caps to not let spending get out of control like this. And that was kind of the other point I was making. Like, you know what? There needs to be a restraint, needs to be put on the owners of the higher leagues, especially, and this is especially true in major league sports here in the United States, is that both the players and the owners come to an agreement in terms of what a salary structure is all about. You know, and there's an agreement for that, you know, and you know, it's not just a unilateral decision. You know, if you have a salary cap structure, yes, then that means that certain teams like, say, the Yankees in baseball can't be spending all willy-nilly without some penalties associated with that, or cannot go over a certain amount of money they can spend every year, so that way they don't feel like, you know, this is the team that wins every year. Like, Okay, no, there's penalties to pay for that. There's consequences for that. So I just feel that that's what fans are so used to, that they're very complacent about it. They're so used to that system that you should have been asking for this years ago, rather than this actually being happening right now. And it says, I mean, here's the worst part. Everyone signed on Saturday. It's a binding deal. So who will be the next to sign? We need to keep working. We've done a poll on the fans in favor of all 5 countries we did it in. It'd be fascinating to see the methodology of this survey. Apparently, it was the football fans over 15 years old. In each country, there for those in favor of the Super League were as follows: 72% in Italy, 71% in France, 59% in Germany, 57 in Germany, 59 in England, 76 in Spain. We need to see the actual question they ask and how they select a fan. That's true. Actually, since it's a statistical survey, actually, related to what I'm doing here in class, yes, the way you ask a question is very important, and your options are also very important. Plus, exactly where is it an actual random sample? That's very important. Yeah, it's pretty disrespectful. I ain't gonna lie. Yeah, I agree with that. Tis a sad day in football, Connor. A very sad day in football. Wow, that's really good. Ooh, ooh, I like this drink. Oh wow, that's really good. Dang, it's pretty outstanding. Well, can't really argue. First time having this grape juice drink, and this is like good stuff. Mm. All right, ladies and gentlemen. Ah man, ay ay ay. 5 invited teams. We talked to 3 countries. We'll talk to FIFA and UEFA like they'll ever talk to you. You basically destroyed them. So I don't know if FIFA or UEFA will ever talk to you. It's not a closed league. Well, you basically made it an elitist league. So yeah, it's a closed league as far as they're concerned. I mean, look at this. England and Germany do not favor this whatsoever. I can understand why France and Italy and Spain would favor that, because they have fewer good teams in their leagues. Like I get it, you know. Italy has Juventus, and it's like, okay, you have Juventus and AC Milan and Inter Milan. Like, okay, that's fine. France has, PSG, and of course Spain has, Madrid and Barca. So I'm like, yeah, yeah, that's the feels right there, man. The feels bad, man, right there. That's rough. That's rough, dude. It's really rough. All right. Well, we got to get going here. I got to get started with some material. Let's do this, ladies and gentlemen. All right. Get started here. Let's do this. All right. Okay, let's get started today. Welcome back to Monday. Hope you had a nice weekend. All right. So today, ladies and gentlemen, last time we just ended up doing the one section here. They believe you guys voted. You're like, let's just do section 11.3 and be done with it. So this time, we're going to be doing a couple of sections here. Again, we're getting very close to the end, so we'll get these next couple sections out of the way. Again, we're doing the last part of Chapter 11 in Section 11.4, and then we're also going to be starting on Chapter 12, Section 12.1. We'll see how far we can get here with these 2 sections, but we'll be going over these questions here a little bit more carefully. All right, so let's go ahead and go to the big board here. And I need to get my section 11.4 out here. Hey, Natty, how are you? All right. Again, today I'm just gonna give you guys a friendly reminder here. Today is gonna be very heavily reliant on the calculator. Okay, so the calculator is gonna be our kind of our best friend here. I'm doing wonderful, Natty. I'm doing absolutely wonderful. It's been a good day so far outside of, well, talking about football. I know that's a rough go, but yeah, overall it's been a very good day. Okay, so last time we looked at, let's say, I believe 11.3 was like matched pairs data and stuff like that. We took a look at all that stuff there. Today we're going to be doing the last part of looked at, oh, I should say two means. That's what we looked at last time. Well, today we're doing section 11.4, which is doing hypothesis testing with two population standard deviations. So that's what we're going to be doing here in this case. We're going to be given two population standard deviations, again, two different data sets. And we're going to be, of course, comparing the two here and making a hypothesis test out of it. All right. Agreed. Agreed, Connor. I agree. Okay, so let me actually. I don't know why I don't have this up, but I do need to have this up here. By the way, just to let you know, um, while I'm doing this here, that once we're done with chapter 12, okay, which is 3 sections, so there's 12.1, 12.2, 12.3, so we'll be working on the first section here today. That is going to be it for the material, okay? So just to let you know, after section 12.3, that's it for the material there. We'll talk about, all right, Connor, you too, man. We'll talk more, okay? But after section 12.3, we'll be talking about the last test here over these last few chapters, and then we'll also talk about the final exam as well. So we're getting geared up for that here because we're getting close to about that time. All right, and we'll be talking about that fairly soon. Whether that be on Wednesday or next week, I'll be making some kind of announcement in regards to both of those things, as I do have some things in mind. Okay, so more than likely, I'll probably make it next week, but again, I want to be sure that everybody is on the same page here when it comes to something like that. Um, I haven't made the test up just yet, or the final just yet, but I have a very good idea already about what I want to put in and what the rules will be and all that stuff. So, but I want to kind of announce that kind of at the same time so everybody knows what the story is, so they don't know. They're like, oh my gosh, what happened? And I'll be like, oh yeah, this is what happened. So we will certainly talk about that when it comes to that. All right. We go to this page here. Eventually, I'll get to it. Oh, all right, we go. Alrighty, let's do it. Okay. I'm gonna take a look here at the book. We'll also take. Oh, no, I didn't want to do that. Why? Why do I do that? Why would I do this to myself? Oh my god. All right, so let's look at the steps here in this particular case, and let's look and see how we can figure out this hypothesis testing. All right, so all the steps here are going to be pretty similar to what we've done before. There's no major changes outside of course, the perspective that we're looking over. Okay, so nothing big is happening here. We just have to do a little bit of a setup. So let's at least go through this here very carefully. All right, first of all, step one here, determine the null and alternate hypotheses. Now, basically, as it's going to work here is that we're going to have two population standard deviations. So one for group 1 and one for group 2. So this is going to be always the same static null hypothesis here. Is we're going to have the population standard deviation of group 1 is going to equal the population standard deviation of group number 2. And once again, we have our left, right, and two tail as we've talked about before. Okay, so again, less than, bigger than, or not equal to. Again, as always, dependent on the wording of the problem here. As we've pointed out here for many of these examples, the wording here is really what's going to give it away. So we'll look at that here as time goes along. And then state the level of significance. And then we'll get to the test stat and the p-value and that stuff here. But let's focus on the first three parts here once again, so that way we have a good idea about how to set up this problem here. And then we'll look at, once again, the test stat, the p-value, and the comparison we'll make here at the end. So a lot of things here are pretty much exactly the same as they were before. Again, read the problem carefully though, because we had a couple issues here last time, so I want to be sure that everybody here is on point. Okay, so let's go ahead and okay, that is on the screen there. Very good. Let me make this a tad bit bigger here. So, all right, there we go. Hopefully that's not covering the screen. All right, it's not. All right. So let's take a look here. Tool here. All right, good stuff. Okay. So let's go ahead and we're going to do number 15 here, and we're going to go over the steps here once again. The one thing I would like you to do, though, here specifically, what I would like you to do is, again, just label your group 1 and group 2, so that way you have your data in the right places, all right? So it's not like you don't know what's going where, okay? So we'll look at that here in just a moment. All right. In any case, let's look at number 15, elapsed time to earn a bachelor's degree. Clifford Adelman, a researcher with the Department of Education, followed a cohort of students who graduated from high school in 1992, monitoring the progress of the students made toward completing a bachelor's degree. One aspect of his research was to compare students who first attended a community college to those who immediately attended and remained at a four-year institution. The sample standard deviation time to complete a bachelor's degree of the 268 students who transferred to a four-year school after attending community college was 1.162. The sample standard deviation time to complete a bachelor's degree of the 1,145 students who immediately attended and remained at a four-year institution was 1.015. Assuming the time to earn a bachelor's degree is normally distributed, does the evidence suggest that the standard deviation time to earn a bachelor's degree is different between the two groups? Okay, so again, let's talk about both groups here first and foremost. All right, so let's look at group 1. So group 1 here will be community college. So from community college to a four-year, right? And then group 2 will be just a straight four-year. All right, so like a straight four-year. All right, now I've went ahead and labeled our guys. Now, the next thing that we're going to do here specifically is let's go ahead and do our particular steps. So now that we understand what our groups are, let's go over the steps here. First of all, our null hypothesis. As stated here, our null hypothesis, we're going to automatically assume that the population standard deviation of the first group is equal to the population standard deviation of the second group. All right, like I said, these are set in stone. We don't need to really worry about the null hypothesis. It's always going to be the same for every single problem. Very convenient, especially in problems like these, to reduce the amount of confusion that we'll have here from the get-go. Now, the real question is, of course, is our alternate hypothesis. Like, what claim are we making here at the end of the day? So what is the alternate hypothesis here? Remember, we have the three choices here: less than, bigger than, or not equal to. So what do you think here in this instance? Not equal, okay. And Massimo, what would be the key? Yeah, what would be the key point, keyword here? Pardon me, for thinking it was not equal. Different. Okay, very good. That's right. So as it says here, does the evidence suggest that the standard deviation time to earn a bachelor's degree is different between the two groups? So different here, 100% correct, absolutely right. That would indicate a not equal to case here in this instance. Perfect. All right, very, very good. All right, so knowing that, what type of test do we have here? What type of test do we have then, if it's not equal to? I know I asked this a lot, but again, a two-tailed test. That is correct, Susan, right. 100%. All right. I'm glad you guys. Yeah, I know not a lot of people from our class actually show up to our lectures too often, but still, I'm glad you guys pick up on this really quick. This is really good. So, I'm really happy. I'm really happy for the people who come. Really happy to see like a lot of good progress you guys have made for a lot of these type of tests. I know at first it was pretty tough, but with the foundation and like the templates we put down, you guys have really picked up on a lot of things really quick. So I try and make this as simple as possible, and I'm glad that everybody has done really well when we're going through these examples. So I'm really encouraged by that, like seriously. Um, all right. Step number 3. All right, step number 3. We'll just state the level of significance here. Again, that's just given to us here because I'm the best. Oh no. You guys put in the work and the time. You know, I'm a facilitator of information, but you guys put the real work and the time here. I'm impressed by what you guys do, and at least starting to pick up what I'm trying to dish out. I'm not the easiest to necessarily get along with, but you guys have put up with me for the past like three months or so. So yeah, uh it's not me, it's you. You guys do all the work, and I'm really proud. Honestly speaking, even though we're heading down to the end, and I guess I'll just say this as an aside here, but for everyone who comes to these classes consistently, and for those who even work offline, because maybe, or even if you come to these classes, I'm really proud of all of you for putting in the effort and the time. I know that stats isn't the most exciting class in the whole wide world. I get that some of it's not going to be useful to you. I get that. All right, but I'm glad that you guys have put in the time and the effort to really care about yourselves, care about your academics, and really you guys have shown a lot of growth here for the past 3 months or so. I'm really proud of all of you. So thank you very much. You make, like I said, you that's what I say at the end of every lesson. You guys make this all worth it at the end of the day because of things like that. It's little by little I've seen a lot of improvement. So really happy to see that. All right. Okay. Now, let's talk about the next step here. I know that's a little cringy, but still wanted to at least say it. Okay. So, the next thing here I would you're like, you're so cringe. I'm like, yeah, dude, I am, because you know what? It's okay to pat people on the back when they're doing a great job. You're like, you can't. I am. I'm doing the right thing. And how many times are we praised for the doing the things that we're supposed to be doing? Sometimes you're not. So it's good to be recognized every once in a while. All right. So let's look at step 4. All right. Step 4 here is to compute the test statistic. Now the test statistic here is basically labeled in this case as F0. Okay, not the game, but F0 here. Uh, and that's equal to, again, the standard deviation of group 1 squared divided by the standard deviation of group 2 squared. Actually finding this out via by hand is actually fairly easy, but there is a little bit more involved in this than just the standard deviations here, even though that's the test stat. There are like degrees of freedom to consider. So the test stat here is pretty easy, but then you throw in degrees of freedom, it gets to be more confusing. So I'm not going to get too much into it here, but the test stat here, what I'm going to do here is just write in the test stat. We're going to find this test stat here via the calculator at the same time, just as usual. All right, but we do want to note some information here, just like we did from before. So let's understand that we're still going to want the sample standard deviations of both groups. And we're actually also going to note the sample sizes of each groups as well. So let's go ahead and at least state those here. So as we can see here, the community college sample standard deviation, we'll label that as S1 here, is going to be 1.162. All right. And the sample size here, I'll label this as N1. The sample size here for the first group is going to be 268 students. So 268 here is going to be the sample size for the first group. Sample size for the second group here, actually, let me put that in a different color. Red? No. You know what? All right, we'll put sample standard deviation for the second group here is going to be 1.015. And then we also have the sample size for the second group, which was noticeably larger, which at 1145. So there we go. There we go. We have both sets of information here given to us in this particular problem. Alrighty, good stuff. Now, having said that, let's go ahead and talk about how to find our p-value here, which is what we're looking for, and we'll do this here together on the calculator. Okay. All right. Okay. So the p-value here is we're going to use the calculator for this, of course, just like we had from before. And the calculator function that we're going to use here is what's called the two-sample f-test. So remember that the notation here is f0. Well, that actually is rather important because this is a two-sample f-test. Now, let's go to the calculator here for just a moment because let's at least put this in appropriately, and I'll show you here the steps about how to do that. Bust out the calculator here. Get things rolling. All right. No. Whoop. Okay. Rah. Let's do this right. All right. Okay. So I'll give you a few seconds here to grab your calculators from wherever they are. All right. Get going here. All right. So let's go ahead and hit the stat key here on the calculator. And we're going to go over to tests. All right. Just like so. Now, where we need to scroll to is we need to scroll to letter E. So letter E says two-sample f-test. The F looks a little funky, okay, but it is the correct test here. So letter E here, two-sample f-test. All right, and we'll just go ahead and hit enter on that. All right, in this case, and we'll see, looks pretty gosh darn awful. See? Let's try again without looking terrible. Go. All righty. All right. We'll hit enter on that. Now, as you can see here, what we have is we have two options once again. Either we can be given a data set here, or we're just given stats. In this case, we're given just the stats here straight up. So we're going to leave it on stats and hit enter. We'll go down here to the first one here, which is the sample standard deviation of group number 1. As we noted here in step 4, that's going to be 1.162. N1 here, again, our sample size for that first group will be 268. Sample standard deviation for group 2 is going to be 1.015. And the sample size for the second group was 1,145 students. As noted from step 2 here, just like we had before, two-tail, left tail, right tail, just as it was before. We'll go ahead and go to two-tail, hit enter on that, and there we go. We'll go down to calculate, and let's see what we get for both guys. Alrighty. Okay, so looking at both particular guys here, let us see what we get for our values. All right. So our test stat here is this very first one that says F. All right. So we'll hit 1.3106 for our test stat. And our p-value here is 0.0036. All right. So no problem here. Easy peasy lemon squeezy. Okay. All right. So now we have our test stat and we have our p-value here, just like we have from before. Now all we have to do here, from here on out, is just go ahead and take a look at step 6, which is the same step 6 that we've been doing here pretty much the entire time, with the exception to one section. But in this case, you don't have to worry about it. It's the same conclusions that we've already set before. Again, we just compare the p-value to the level of significance. So once again, the p-value is less than the level of significance, we reject the null hypothesis and accept the alternate. Otherwise, it's just the opposite, accept the null and reject the alternate. So again, we just ask the same question here, like we usually do. So is, looks like p-value here is 0.0036. Is it less than our guy here, our level of significance, which is 0.05? So 0.05 here. So this boils down to a yes or no question. So yes or no, is 0.0036 less than 0.05? Yes or no? Yes. Yeah, is right. I agree. The answer is definitely yes. Okay, it is definitely less than 0.05. So we can make a conclusion here. We can reject, null, and accept the alternate. All right, and that's going to be our final answer for this problem. All right, good. Any questions about this first example? Oh, no says to hydrate. You got it, my friend. Thank you. Oof, that's so good. All right. No. Oh, now Natty wants me to. Okay. Hydrate again. All right. Well, you ask and ye shall receive. That's just how it works. That's how it works. All right. And you guys are such trolls. Ah. All right. There we go. I've hydrated 3 times, and I'm glad. In some cases, I'm glad this is not beet juice, where I'm probably gonna be like hitting the restroom like 40 times, in one stream or something like that. So yeah. Mm. You're like, you gotta run to the restroom again. You're never gonna get to this example. Like, yep. Look what you have done to me. Push the button 20 minutes later. Well, I'm still going, folks. I'll be back, in 20 minutes. That's like. Ay, ay, ay. Oh my gosh. That's hilarious. Alrighty. Good stuff. Okay. So that's how we can handle that one right there. Alright. So it looks like you guys picked up on that rather quick. That's good. Alright, let's do one more here. Let's do one more here. Alright, so we're gonna do number 19. Alright, so we'll just do that one here really quick. And we should have that fast and simple. Let's go ahead and do this one out. Boop. All right. Okay, so number 19, it says waiting time in line. So McDonald's executives want to experiment with redesigning its restaurants so customers forming one line leading to 4 registers to place orders rather than 4 lines leading to 4 separate registers. They redesigned the 30 randomly selected restaurants with a single line. In addition, they randomly select 30 restaurants with the 4-line configuration to participate in the study. At each restaurant, an employee monitors the wait time in minutes of randomly selected patrons. The following data is collected. So here you have the number of minutes that a person had to wait in line before they got their order in. All right, and let's go ahead and answer the question here. Is the variability in wait time in the single line less than that for multiple lines at the 0.05 level of significance? Actually, ironic thing about this, fun fact about this particular problem, this actually was actually McDonald's used to have multiple lines. Like that part is actually true. There used to be like 4 multiple lines with 4 cashiers on it, and they did switch it to a single line, which is what you find in most fast food restaurants because of studies like these. All right, they found that it takes less time to actually fulfill orders if you have a single line. That's why you see, like, when you walk into a fast food place, that's why you see a single line going to the registers. It's actually significantly faster. So, to get orders done. So, yeah, there is actual like this is good data to actually prove that actually works. Um, Multiple lines is pretty bad because it depends on who's in front of you and how big their order is. So your wait times could be significantly longer. So if a person in front of you has like a family of 4 and you're just by yourself, their order is going to take significantly longer to make, and then you're going to have to wait in line longer. That's why one of the things about like if you talk about like theme parks, right? Same thing with theme parks too. That's why theme parks make you wait in one line as opposed to multiple lines because of that same fact. So the only multiple lines that you see is, of course, to get onto the actual, say, roller coaster or ride. But yeah, it's actually a single line actually makes it go faster, despite the waiting times. Of course, I know they're pretty busy in certain rides. So, all right. In any case, let's take a good look at these guys here. They're not too hard. All right. Uh, okay, the 20. Okay, that's fine. All right. So here, what we're going to do is we're just going to go through each one here. We'll select the groups here. All right, so group 1 and group 2 are pretty easy here to distinguish. Group 1 here is the single line. Single line, and group 2 here is the multiple lines. Okay. So step number 1 here is, of course, just understanding that we have the population standard deviation of group 1 equals the population standard deviation of group 2. So again, that's not changing. It's the same. All right. Oops. It would be helpful if I put that as H0 for our null hypothesis. My bad on that. Okay. Now, what is the alternate hypothesis? What's the alternate hypothesis here? Is the alternate hypothesis here is that less than, bigger than, or not equal to? Susan says less than. That is correct. Okay, absolutely correct. All right, 100% correct here. Again, is the variability in wait time in single lines less than that of for multiple lines? So this is where again labeling your things is very important. Once you label your groups here, then it's easy to figure out less than, bigger than, or not equal to. You just follow the path of what the wording says. All right, what type of test we got here? Type of test we got here. Hopefully this is easy peasy lemon squeezy. Left, yes, indeed. All right, so we have a left tail test. All right, easy time, easy life. All right, so we're just buzzing through this like it's no tomorrow. All right, step 3 here. All right, alpha here will be equal to 0.05. So we'll have no issues with that whatsoever here. Simple enough. All right. Now, step number 4 here is, of course, doing our test stat. Again, we don't know what our test stat is. We'll figure that out, of course, at the same time we get our p-value. We'll just write both of these guys in just like so. We'll, of course, need to make some adjustments here to find the p-value, but let's do that here together. Alrighty. Let's get going here with our p-value stuff and putting this stuff in. All right. So what we're going to do here first is we're going to go ahead and hit the stat key here. We're going to go over to edit. Now, if you have stuff already put in for list number 1 and list number 2, we're going to go ahead, highlight the list, hit the clear key, hit the enter key to clear out those lists. So hit the highlight the list, hit clear and enter. That will highlight, that will clear out the list here. No problemo. Now we're just going to put L1 to be all the single line data, and L2 here will be all the multiple line data. So be sure to go over this carefully here of what you see here on the screen. All right, yeah, just be careful when you enter in all the data points. Okay, so okay, so you should have 20 of them in there, and I do. Okay, multiple lines. Okay. So I'll just wait for, once you have that entered into your calculator, please type done in the chat. Why is my nose so runny? Give you guys a little time here. Okay, Susan, Massimo, we're done. We'll wait for another minute. We'll wait for another few, little bit. Some people just are typing carefully, so. All right, Natty's done. Okay. All right, good stuff. All right. Let's go ahead and take a look here at, all right, so now that we have that put in, let's go ahead and hit second and mode to quit out to the main screen here once you have that entered in. So as you've all stated here, we're going to go ahead and hit the stat key here. I'm going to go over to tests, go down once again to the 2 sample F test like we have from before. We'll hit enter here on the 2 sample F test. This time, however, instead of stats, we actually have data sets. So we're going to go over to data and hit enter. So what we have here, of course, is we have list 1, which is actually L1. That's our single line guys. List 2 should be L2 by default here. Again, if it's not there for list 1, you can hit second and 1 for list 1, second and 2 for list 2. These 2 frequencies should remain at 1. You're not going to touch those. And of course, the type of test that we have here, which was a left tail test according to what we had said earlier. So here, we're just going to highlight this guy here for a left tail test. We'll hit enter and go down to calculate. All right. So let's go ahead and take a look here and see what we get. So I'm just going to kind of float it down here. All right, and let's write in our results that we get. So here for our test stat, we have 0.3219. So that's our test stat here, 0.3219. Our p-value here is 0.0087. Okay, so far so bueno. All right. Now we just move on here to the last step. Let's do that. So step 6, just comparing the p-value here once again to our level of significance. So is 0.0087 less than 0.05? The answer is absolutely 100% yes. All right. Very good. And so what conclusion can we make then? What's our conclusion then? All right. Sounds good to me. Excellent. Excellent, 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 everyone. All right. Reject the null and accept the alternate. Good. Okay. And that's our final answer for that with a data set. All right. Wonderful. Any questions about that? Any questions at all? Nope. Nope. All right. All right. So, really quick question here for everyone here. Is it okay if I keep going here? I can forego doing a break because I can do 12.1 rather quickly. Is that okay with you guys? Okay. All right. All right. I just want to be sure on the safe side here. Okay. I don't want to be like, hey, I'm going against what I said. I have to ask first because you guys voted on that a long time ago. Got to honor the promise. Very important. All right. Okay. So let's move on here then to section 12.1. All right. So that's the end of chapter 11. All right. So that's all we're doing for chapter 11. That's done and dusted. All right. Now we're going to move on here to chapter 12. So chapter 12. Did I have the? Let me check something. Where did I put chapter? Oh, I guess I closed it out for no reason. Let me give this thing up. There we go. Yo, what's up, my dude? You got a question for me? Go for it, bro. What's good? Depends what you're interested in. Exactly what kind of good are we talking about here? Food good? Drinks good? You know, it could be anything. That's not the question. Okay. That's not the question, but how's discrete math? Discrete math is okay. It takes a little bit of getting used to because you have to do a little bit of proofs in discrete math. So, you just have to follow the logical processes. Like I said, discrete math takes a little bit of work, but it's not like horribly terrible. I guess not terrible, terrible. So, like I said, though, it does take a little bit of getting used to. So, definitely have to be in the mindset of doing logical processes and making sure that you go through it one step at a time. That's how discrete math will work. So, it is going to be, you're going to take a prior. It is important to take prior to starting CS. Yeah, I could understand that. It is one thing that's going to be very helpful for you is knowing logic is going to be incredibly important for knowing how to work with CS because everything you do in computer science is basically revolves around putting the logic together and making the language work with the logic. So having that background is fairly helpful. I won't lie. That's why I did a math and CS degree because it really helped out. Now, you don't have to go as far as I did, of course. Like getting up to Calc 1 is pretty much mostly what you need. But yeah, having that logic background really helped out a lot when I was doing like electrical engineering and doing like some basic coding. I was like, oh, one step at a time. What's this function doing? Okay, it's doing this based on what logic it's putting out. So um, and over time you're trying to figure out how to be more of an efficient coder and those sort of things. But you get the general idea. Um, uh, skip pages here. There we are. Perfect. Perfecto. All right, could make sure that. Alrighty, got it. Okay. I hope that helps there. I hope that helps you there, Rakat. You know, that's what I did discrete math. That's basically how it was. Logical processes. That's my full and honest answer to you, my friend. Alrighty. Yeah. All right. So let's go over section 12.1 here. Section 12.1, how do we do a goodness of fit hypothesis testing? Okay, so goodness of fit hypothesis testing basically is going to take a look at a data set and see how well it fits with the template that we're given here and basically making a comparison at the end of the day. All right. And really, actually, goodness of fit hypothesis testing is actually fairly straightforward to do. We just have to do a little bit of setup work here before we actually put anything else in. So um, you'll understand how things work here in terms of what we're doing here. We actually, in this case, actually, it's actually even a little bit easier than maybe what we've been doing before. I'll explain that here in just a moment, which will be here in step number 1. Step number 1 is, of course, determine the null and alternate hypotheses. However, the null hypothesis and the alternate hypothesis are both nice and static. Essentially, the null hypothesis says the random variable follows a particular distribution. So you're going to be given a fact that it's going to follow a particular distribution, whatever data that you're given here. And you're just going to say, hey, it follows this distribution right here. Okay, that's my null hypothesis right then and there. My alternate hypothesis basically says it doesn't follow that distribution. That's it. So it either follows the distribution or it doesn't follow the distribution. And those are nice and static and set in stone. So the one drawback to this, again, or not even a drawback really, is that we're no longer dealing with, in this section here, we're no longer dealing with left, right, and two-tail. Okay, so there's no left tail test, there's no right tail test, there's no two-tail test, nothing like that. Now both things are static and set in stone. So follows some distribution, doesn't follow that some distribution, donezo. Simple enough. All right. So since we don't have a type of test here in this case, I went ahead and I said, all right, state the level of significance. That's going to be step number 2. Okay, so whatever level of significance we're given, that's what we're going to be working with. Seems fair. Okay, now I'm going to get here to step 3, which says list your observed and your expected values. And we'll talk about this here in just a second, but I did put a note here. Your expected values are based on the type of distribution it should follow. All right, I'm going to stop right there at step number 3. We're going to do these first 3 steps here because the third step especially is going to set us up for the remaining steps in this process. Okay, so it is important for us to be very careful about that because we do need to keep that in mind. Okay, so I'm going to look here at number 11. All right, and then I'm going to talk about the observed and expected values here because that's really the big crux. That's the biggest portion of the problem here that we need to be very aware of. All right, so let's do that right now. Okay. So let's do 11 here. 11 is one of the best examples that we can make here for problems like these. So let's do this. All right, plain M&Ms. So according to the manufacturer of M&Ms, 13% of plain M&Ms in a bag should be brown, 14% yellow, 13% red, 24% blue, 20% orange, and 16% green. A student randomly selected a bag of plain M&Ms. He counted the number of M&Ms that were each color and obtained the results shown in the table. Test whether plain M&Ms follow the distribution stated by the Mars Company at the 0.05 level of significance. Holy crap! What the heck? Oh, are you okay? Holy moly! You alright, cat? Holy moly, dude. Don't scare me like that. Is everything okay? Is everything okay? Now, I believe you, dude. I'm not doubting what you're saying to me. Are you okay though? That's that's what I'm asking you. I want to be sure that you're safe. Oh, dude. Holy moly. I'm just glad it wasn't I'm just glad it wasn't your I'm just glad you were able to put that out. Maybe your headphones were destroyed, but you know what? At least the rest of your place is okay. So, yeah, just be careful, man. Yeah, oof, that was close. Yeah, don't scare me like that, man. Maybe you're gonna have to consider putting that candle somewhere else where it's not gonna be catching fire to anything that has sensitive equipment. I don't know, but yeah, that is not good. I'm glad. Look, hey, I'm glad you're. I'm glad you're effing lucky. It's okay, man. It happens. Look, you're human. It's not a problem. Those things happen. Okay, serious or not. You're. The only thing that matters here is that you were able to put it out and you're safe. Okay, it's fine. Don't worry about it. You're human. It's okay to put something out like that. That's how you honestly feel. I'm not gonna hold that against you, buddy. All right, no. You're human, and you were put it. That's a high adrenaline situation. So you know, don't worry about it, man. You're good with me. No, nobody likes things like that. So, oh well, he almost his place almost caught fire because of his headphones was put next to a candle. So one of his batteries almost exploded because the fire was that close to it. So they burned in flames. Well, look, the headphones burned in flames, but your place didn't because you put it out in time. Loss of some headphones, loss of headphones pales in comparison to anything else. Your life, okay? Remember, that's a lot more valuable than one pair of headphones ever will be. Okay, so don't worry about it. Long as you're okay, I'm happy about that. Yeah, you know what? $80 is nothing compared to your own life. Okay, $80 means nothing. All right, it could have been thousands. It could have been your own life. So don't worry about that stuff. Like things can, to me, it's like things can be replaced. Okay, but your life is not one of those things that can be replaced. Okay, so your safety is the first thing that you need to think about, and then whatever is destroyed, you can go ahead and think about it later after that. So I've crashed cars before. I'm sad that my cars have crashed, right? And I, basically lost the car, but I didn't lose my life. And like car is replaceable. It gets me from point A to point B. But it would be bad if I lost my life. So, but I'm very happy that you're okay. Thankfully. All right. Woo. Close. All right. Nah, man, it's all good. Take your time, okay? All right. Always it's adrenaline, man. Yeah, I don't blame you for typing that out. Adrenaline, man. 100% adrenaline. All right. Okay. All right. Let's go to step one here. We're talking about M&Ms here. Thankfully M&Ms don't burn. Um, that that hard. That that's so nice to burn and kind of melted chocolate. Anyway, I digress. All right. So step one here is that again we want to state the null and null hypothesis here. So null and alternate hypothesis. So here's the way it works. The null hypothesis here is going to work like this. It's just going to be basically that the bag follows basically the bag follows the company's distribution. So the company has like a set kind of distribution, right? They basically have said, all right, this percent needs to be this color, this percent needs to be this color. They're like, okay, fine. This is what it has to be. That's what they set in stone. They're like, this is what it should be here if we make a bag of M&Ms. Fair enough. The alternate hypothesis says it doesn't. All right? That's basically it. Does not follow the distribution. Alrighty. Good beans. Now, step number 2 here, we're going to state the level of significance. So the level of significance here in this instance is just, again, since there's no left, right, or two-tail test, this is just going to be 0.05 here in this case. Okay, so that's what's given to us here in the problem. Alrighty. Now comes the most important part of the problem here. Okay, which is, in my opinion, this is the most important part of the problem because in order for us to actually get the rest of this stuff here, we need to actually set up this problem here appropriately in order to get the values here to work out. All right, so step number 3 here, let's go over step number 3. We want to list our observed values and our expected values. All right, first of all, we can list our observed values. So what we're going to do is we're going to make a list here for each. All right, we're going to make a list for observed. All right. Now, the list of your observed here specifically is going to be what you see here on the screen. Okay, so 57, 64, 54, 75, 86, and 64. So for each one of those guys here, for each one of the colors here, I'll just label the colors here as well. Brown, yellow, red, blue, orange, and green. I'm just going to paraphrase to make this easier on myself. So again, these are the various observations here for each one of these colors, respectively. Red, 86, and 6. Okay, now let's talk about what's going to happen next. Okay, now we have an expectation here. Now that expectation is based off of the manufacturer's recommendations. All right. Now to get this expected values here, we're going to need to use the distribution that the manufacturer had set aside. But we first need to figure out, first and foremost here, how many M&Ms were in this bag. Okay, so this could be like a super king size bag of M&Ms. Okay, all right. How many M&Ms were in this bag? So what I would like you to do here first is to add up all these numbers here together. So I want you to add up all these numbers here together and tell me what we got here as a sum. So add 57, 64, 54, and so on and so forth. So 57, and tell me what we got here in this case. Okay, so we got 400 here, right? All right, good. So we have 400 M&Ms in the bag. All right. Now this is very important to know how many M&Ms were in the bag in the first place, because then this is going to help us find what our expected value should be if we actually had just 400 M&Ms and followed exactly the expected value, the manufacturer's recommendations, excuse me. So if I were to look at the expected value here, and I said, okay, well, 13% of this needs to be brown, right? That's what it says. Then this should be 400 times 13%, which is 0.13. Okay? So let's do that on the calculator here really quick. What's 400 times 0.13? What is 13% of 400? What's that going to be? All right, 52. All right, very good. So 52 here is going to be the expected value of M&Ms that should be in the bag if it followed exactly the manufacturer's recommendations. Let's try the yellow one. The yellow one here is 400 times 14% or 0.14. So what do we get there? 400 times 0.14. 56. Okay, good. All right, now the next one here is the same as what the first one was, so we're just going to go ahead and put 0.13 here. This is 13% red, so that's going to be 52 again. Okay, let's look at the next one here. It should be 24% blue. We're just going to do 400 times 0.24. And what do we get here in this case? 96. Okay, so we get 96 here. Excellent. Orange should be 20%. So what do we get here for 20%? 80. All right. Excellent. And then finally, the last one here, we have 400 times 16%. So 0.16 for the 16% here. All right. And we get 64. Okay, good. Okay, excellent. All right. So we have all the values here for our expected list. Okay, so we have our observed values, just our raw data there, and the expected values, which should be our ideal data for the proper distribution here in this particular case. All right, seems fair. All right, so that is step number 3 here. Like I said, that's the toughest step here because this is going to help us set up the rest of this problem here appropriately. Now let's go over that part here in this case. All right. So step 4 here is we have to find the test stat. Now finding the test stat here, this is the formula here for finding the test stat. I'm not expecting you to memorize this. I'm not even expecting you to enter anything in for the test stat here. You can write this down for your notes here if they do ask you about it. I'm not interested really in this test stat for this one because it would take a long time to add all this stuff up, subtract both of them, square it, divide it by the expected value, and then add them all up together. Yeah, it's kind of a pain to do. So naturally, we're going to let the calculator do this in our stead. That's very important. Okay. Now, I put this as a separate step here because of how important this is. We do need this piece of information, so I did put this as a separate step here. That is talking about degrees of freedom. Okay, now, as you can see here on the screen, this is something that you definitely do need to write down. Okay, so I highly recommend you definitely write this down here. Degrees of freedom typically was the sample size minus 1. But not in this case. For a goodness of fit test, the degrees of freedom here is the number of categories. The number of categories minus 1. So understand that if we look at degrees of freedom here, I am not looking at 400, okay? Degrees of freedom here is the number of categories, which i.e. means in this instance are the number of colors that we have here for the M&Ms. So we have 1, 2, 3, 4, 5, 6. We actually have 6 minus 1, which is equal to 5. So that's the one big key piece of difference here that you do have to recognize here in step 5. There are 5 degrees of freedom, not 399. All right, so we're not considering the sample size here, only the number of categories. All right, please be sure you underline that, make sure you highlight that, whatever you need to do. That is the one difference here that we have compared to other sections. Okay. Step 6 here is basically you finding the p-value here. Now, if you have an old school calculator, if you have a really old calculator, you may not have this actually on your calculator if you have a super old calculator. If you have a newer calculator, you definitely are going to have this function here on your calculator. If you don't have this on your calculator here, you're going to have to find something on the interwebs to do a goodness of fit test. Because I'm not sure where you can find it, to be honest. But you should have this on your calculator here. Is the chi-squared GOF test is where you're going to find that here. Let's go ahead and set this up here so we can do this test appropriately here. Okay. We're going to go over this carefully here. We're going to need all that data. It's right below that one, Massimo. Right below that one. It should say chi-squared GOF test. It would be the one below that. Do you have that there, Massimo? I don't know if that's it, but sad boy hours. Yeah, let me show you how at least it works here on this calculator, and then hopefully it'll be, if you see it, then it'll be okay. Let's see if it works. All right, so first things first here, we do have to set up our data set here. So we need to go to stat and we need to go to edit. So at least Massimo, you can follow this part here. We're gonna go to list number 1, hit clear and enter. We're just gonna clear our lists. For our first list, you should put the observed values in our first list. So let's put the observed values in our first list. Okay, in list 1. List number 2 will be our expected list. So all right, so list 1 here will be our observed list. List 2 here will be our expected list. All right, now we're going to hit second and mode here to quit out. We're going to go ahead and hit the stat key here. We're going to go over to tests. Now let's see if Massimo, you have this here. It'll be letter D. So letter D here on the calculator will have the chi-squared GOF test. Okay. I don't know if you have that there, Massimo, but that is the option there on the calculator. Ah, crud. Okay. It actually does make a significant difference here. Let me see if I can find it here. Here, try this and see if it works. I don't know if this will work, but let me put it as a link in chat. See if this helps. See if this part helps. and then see if that works. I'm not sure if that will work, but that's the first one I found there, Massimo. Or actually, you know what will be easier? Hang on a second. I might have one for you. I might have one for you. That's easier than that one. Hang on a second, Massimo. Here, try this one. Try this one instead, Massimo. See if that one works, and then if that one should be a bit easier to use, I think, in my opinion. So use that. Save that on your browser if you get the same results that I do, and then we'll see what happens here. Okay. So let's try this together now. Okay. So we're gonna go to. All right. So let's do this together here, everybody. All right. So we're gonna go to GOF again. What we have here specifically is we have the observed values here. The observed should be list number 1, so L1. Our expected here will be list number 2, or L2. Again, hit second and 2 if it's not listed there. Our degrees of freedom here are indeed 5. Again, if this is a different number, go ahead and change it to your proper degrees of freedom. That's why we note in step 5 our degrees of freedom here, so we know what number we need to put in that spot, because it doesn't always come out to 5, by the way. And then we're going to go down to calculate to get our test stat and our p-value. Okay. Let's take a good look here at what we get here for the test stat. The test stat that we see here is going to be 6.7443. And we have a p-value here. As you can see, the p-value here is 0.2404. Okay. Got the same result? Excellent. All right. So that's go ahead and bookmark that, Massimo, so you know to use that there for that particular section. Okay. So we got a workaround for you. That's good to hear. All right. Okay. Let's move on to step 7. There is a step 7, by the way. Don't worry about this last part here. This doesn't mean anything. All right. Last step here is exactly the same step that we've had in pretty much every hypothesis testing with the p-value. Once again, making the same comparison as before. No difference, no change. We just answer the same questions as we do before. Is the p-value here 0.2404? That less than our significance level, which is 0.05. Okay, so in this case, it's 0.05. So yes or no, is 0.2404 less than 0.05? Yes or no? No. Okay, definitely not, right? So what conclusion can we make here in this case? All right, perfect. All right, excellent. Accept that null, reject the alternate. Okay, so in this case here, the bag was within acceptable conditions, all right, in terms of the manufacturer. So, okay, good. Still follows that distribution. Excellent. Very good. Questions about that? All right. Now, let's see here. I'm going to do one more here. I do have to do this other one. Okay. So let's take a good look here at number 20. Going to look at that particular question, and then we'll call it a day after that. Okay. It's not a very hard problem. Just again, just setting it up here. Still take a little bit of time. That's it. Okay. All right. 20. A researcher wanted to determine whether bicycle deaths were uniformly distributed over the days of the week. She randomly selected 200 deaths that involved a bicycle, recorded on the day of the week when the death occurred, and obtained the following results. The data is based on information obtained from the Insurance Institute for Highway Safety. Is there a reason to believe that bicycle fatalities occur with equal frequency with respect to day of the week at the 0.05 level of significance? All right, so let's talk about each step here, going down the line. And there's one thing that does make this uniquely different. First of all, let's talk about the null distribution here. Now, it does follow a particular distribution. Can anybody tell me here what kind of distribution is that going to be? What kind of distribution would that be here? Read the problem carefully. What kind of distribution does it say it could follow? Yes, that's right, Susan. That's right. That's right. A uniform distribution. So this follows a uniform distribution. That's right. Now, the reason why I point this out here specifically is because this does have a great impact here in terms of what we're going to be doing in the middle of the problem. Right, so this does follow a uniform distribution, so keep that in mind. Kind of keep that in your back pocket here. Uniform is going to be kind of the big deal here when we talk about our observed and expected values. All right, H1 here, of course, it doesn't follow a uniform distribution. All right, so I'll just paraphrase, does not follow. Does not follow. All right, we'll just paraphrase a bit. There we go. Simple, simple. All right. Now, next, step 2. Step 2 level of significance here is going to be 0.05. So just as the usual problem, easy peasy lemon squeezy. All right, now step number 3 here, we're just going to go ahead and do our observed, and then we'll talk about the expected here. So we're trying to make our observed and expected. All right, that's what we're trying to do here. Got to make both lists. So let's go in order of what's written here in the book. Again, it starts at Sunday, goes all the way to Saturday. So we'll go again Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay. So there we have all the days of the week there. No problem. Pretty simple stuff. Easy peasy lemon squeezy. Okay. Now, first of all, let's talk about our observed values here. Nothing too fancy. It's just the numbers we see there. There you go. Go ahead and put those down. 16, 35, 16, 28, was it 34, 41, and 30. Once again, we're going to go ahead and add these up together here. Want to be sure that this does indeed equal 200. So if we add up these numbers here, do we indeed get 200? Add up these numbers here, do we get 200? Yes? Okay, good. All right, so we want to be sure here. The only reason why I say it adds up to 200 because it does tell us here that she randomly selected 200 deaths. So it's like, okay, you selected 200 deaths, fine, for your study, it is what it is. Now let's talk about the next part here, because that is the important part why I want to show off this example. The rest of it here is pretty much going to be the same old, same old. However, because we assumed at the very beginning this is going to be a uniform distribution, exactly, let's think of the probability that a crash should occur on any day of the week. If it were the case that they would occur on any day of the week and it's a uniform distribution, well, then that means that the probability has to be the same for every day of the week. Okay? This is important because no matter what day of the week it is, you should have an equal likely chance of getting into an accident on any day of the week from Sunday through Saturday here. Okay? So, what that means here specifically is that since we have 7 days of the week, all right, that means that the expectation here, if they were an equally likely chance to happen on any day of the week, should be 1/7. So in a sense, what we have here is we have 200 times 1/7. And you could just leave this as 200 over 7. I'm not going to care about the thing here. And again, because this is a uniform distribution, this 200 over 7 is going to apply to every single day of the week here. Okay, so you're going to have 200 over 7 for Sunday, 200 over 7 for Monday, and so on and so forth. Okay, because it is a uniform distribution. All right, you should have an equal number of deaths here on every single day of the week if it indeed was uniform. All right, so understand that the wording here is, even though the wording here is uniform here, that's why we have just justifies the 1/7 here in this particular instance. Why I chose that here to reflect an equal chance on any day of the week. Okay, before we move forward, are there any questions about that? I want to be sure that I'm clear about that part there. So, everybody okay with that that kind of explanation? Do you want me to go over that again? No, everybody's okay? Again, feel free to ask if you're confused. No? Okay. I want to be sure everybody's on the up and up. So, okay. So we're going to go to the calculator now. Go ahead and put this on the right side here. Calculator on the left side. Okay. So what we're going to do next here to make things as easy as possible, and this also goes for you as well, Massimo. We're going to go ahead and hit the stat key here. Going to go over to edit. Sorry, edit. Let's clear out these lists here. Clear and enter, and of course clear and enter. All right, so what we're going to do here for list 1, we'll just go ahead and enter in our list 1 here. Okay, now for list 2, and I know even for you, Massimo, this should probably work. You should have, just go ahead and let the calculator do this part for you. You're going to put in 200 over 7, okay, just like what you see here on the screen. All right, and the calculator will convert it to a decimal, but instead of typing out the full decimal, you doing it, let the calculator do it in your stead. So we're just going to put in 200 over 7 for each one of these guys, okay? Again, if it's truly equal, it's truly uniform, they should all be the same at the end of the day. Let's let the calculator do that, and we don't have to worry about it, about the long decimals there. Let the calculator do it for you. Okay, so we should have these values entered in for both of our lists here. List 1, list 2. Did you put it in parentheses? Matt, did you put in parentheses there? Try it with parentheses. Yeah, try putting parentheses around 200 over 7. Maybe that'll work. If it doesn't, then just go out to, you can first type out this out to its most amount of decimal places that you get from your regular calculator, and then just copy and paste after that by putting commas in between. That'll work then. So yeah, okay. So just do what I kind of suggested here. Just take that number. Yeah, just take the number there. Take the number, go all the way out to the number, max number of decimal places, and then just copy and paste that, and then put commas in between, and then that should work just fine. And you just need to do that 7 times, okay? So you need to have like 7 of these numbers here. So just to be sure we're on the safe side here, you know. All right, so we're gonna go ahead and hit second and mode. Okay, perfect. All right, so hit second in mode here. Quit out to the screen. We'll hit the stat key here once again. Go over to tests. All right, we're gonna go over to chi-squared GOF test. All right, observed value is L1, expected is L2. Again, though, remember here, this will be the next step in the process here, by the way. Do make a note about that. Hang on a second, folks. Let me quickly do that here real quick. All right, got it. Hang on a second. All right, so we want the test stat and degrees of freedom here. Step 4 is test stat. So this is the part where you do have to be careful about here. Test stat will be equal to something here. Remember that the degrees of freedom are the number of categories minus 1. So in this case here, there are 7 categories for the days of the week, minus 1. So you're going to have 6 as your degrees of freedom. Be sure to change your degrees of freedom here to 6 on your calculator. Okay, so be careful about that. All right, and then we're going to get a p-value that goes with this. All right, so let's go down to calculate here. And let's take a gander what we got here. So we got our test stat here of 19.03. And we got a p-value here of 0.00411. 00411 or 041. Okay. And all we have to do is make our comparison. So again, just as usual, is our p-value 0.0041. Is that less than the level of significance, which was 0.05? Also got the same result. Excellent. The answer is absolutely 1000% yes. All right, so here we're just going to reject the null. Reject the null and accept the alternate. Okay, good stuff. All right, questions about that? Nope, perfect. All right, excellent. Wonderful job, everybody. Hopefully that wasn't too bad. All right, great work, everyone. Okay. And that will take care of section 12.1. And that means that we only have 2 more sections to go, and then we are going to be officially done with the textbook. So it's possible for us to finish here next time. So that may happen. It just depends. In any case, irrespective of what happens here, I guess the first thing that I have to say is thank you so very much, everybody, for coming on out here to the stream once again. You guys are absolutely wonderful. You guys treat me like royalty. I really appreciate it. I don't deserve the praise that you guys give me, but I hope I earn it every single time. Again, I love all of you. All of you are wonderful. All right. And again, I hope to see you all back here, same time, same place, on Wednesday. All right. And as always, everybody, as I like to say, stay safe, stay healthy, and most importantly, stay sane. All right. Everyone, take care of yourselves. Have a wonderful night. You too, Natty. You have a very wonderful night. Have a wonderful, great night here. Take care. Serbando, thank you. Thank you for coming on out here to the stream again. No, I always appreciate you coming out of here every time. So, 100%. All right. Thank you all so very much here, and I hope to see you in a couple of days. All right. Hopefully get these last bit of sections out of the way. All right, guys. Have a wonderful night. Take care of yourselves, and we will see you then. All right, everybody. Take care. Bye.